New groundbreaking research is out from Carl Landsteiner and Harvard Universities, and I'm here to tell you all about it. If you don't know me by now, my name is Amy. I'm a vestibular physical therapist, which means I treat dizziness and balance problems, and I have dedicated this TikTok page to telling you guys all about vestibular disorders. Now, what you need to know about Meniere's disease in order to understand the findings of this study is that Meniere's disease is a disorder of the inner ear. Your inner ear is a series of tubes that are inside your skull bone. So these tubes have bony outer portions that cannot expand, but on the inside of the bony tubes is a pouchy-like structure that is soft and that can expand and contract. And there is fluid called endolymph that gets introduced into this bony labyrinth. And if too much fluid is introduced but not enough is let off on a regular rate, the pouch-like structure can get overfilled and expanded, and that is what's thought to be Meniere's disease. In this study, they did 3D reconstructions and extremely detailed analysis of 19 subjects' ears. 10 people were healthy and 9 people had Meniere's disease. And they honed in on the detailed parts of the inner ear that are thought to be most affiliated with Meniere's disease process. So that is the cochlear duct, the utricle, the saccule, and the Bast's valve, which regulates fluid between the endolymphatic duct and the utricle. And the details that they really focused on were the volume of liquid inside of each compartment, the thickness of the membranous walls of each compartment, and the status of the Bast's valve. So their main findings was that most of the people that had Meniere's disease had an enlarged cochlear duct, one person had an enlarged saccule, and many of them, not as many as that had an enlarged cochlear duct, but many of them had an enlarged utricle as well. Also, not surprisingly, in all the enlarged compartments, they found that the membranous walls of those compartments were thinner. So according to the main researcher in this study, the thickness of this membrane forms mechanical resistance to the increase in pressure of the inner ear fluids known as endolymph, which we demonstrated in a previous paper. This in turn affects the volume changes. So the main takeaway here is if the borders of a sac is really thick, it will not allow expansion. So in healthy individuals, you have a much thicker membrane surrounding the utricle than the cochlear duct. So the cochlear duct will expand a little easier than the utricle in healthy individuals. But many of the Meniere's patients had an expanded utricle. So why is that? The answer to that question, and the most groundbreaking part about this paper, is the Bast's valve. Now, if you recall from earlier in this video, I defined the Bast's valve as the valve between the endolymphatic duct and the utricle, and it will keep too much fluid from entering into the utricular sac. They found that in all the enlarged utricular patients of the Meniere's population, that either the Bast's duct was stuck open or the surrounding membranes were burst, thus causing a dysregulation between the fluid introduction into the inner ear itself. Now, this study didn't solve everything for the Meniere's patients out there, but it sure gave us a step in the right direction for where we need to look for surgical options and medication options for these patients. And most importantly, it gives us hope for all these incurable diseases in the vestibular realm.